G'day guys, Alan here. Welcome back to my workshop, or at least a very small part of it. I'm crouched down between my two milling machines so that we can have a look at the axis hole at the bottom of the bigger one. What this is all about, I want to change to a different sort of cutting fluid, and to do that I have to drain the sump. And there's about, I've got a quick clip here which I'll just show you, which from which you can see from the dipstick there's about 2 centimetres of oil in the bottom of the sump here, so I've got to suck that out. Now in the past I've used this sort of thing for doing that job. It's just like a giant syringe, I guess you'd say, and it sort of works, but it's really inconvenient. And there's a lot of transferring of fluids, and it drips and it's messy. So I want to use this as the basis of a more substantial and usable sort of pump. So let's go and have a look at what my ideas are. Okay, so looking a bit more closely at this pump, both ends have a thread cut in it. It's a 16 TPI thread, and the OD of this tube is 2¼ inches. So of course that's a particularly non-standard thread, but I found this bit of steel tube in the scrap bin, and I think it'll be just fine to accept a 16 TPI 2¼ inch non-standard thread. So let's go over to the lathe and put the thread in it and see how it turns out. Okay, so I've tickled it with a wire brush and cleaned it up a bit on the inside, and hopefully you can see about here somewhere there's a welded seam on the inside of the tube. So I'm going to go in a little bit with the boring bar and see whether we can clean that out to a significant extent, because I think it would be a bit of a problem when I try and cut a thread. So let's see how we go with that. I don't need very much depth of thread or length of thread, probably only about 10, so I'll probably shoot for 15 just so I've got plenty to spare. But anyway, let's see if we can get this seam cleaned out a little bit. Okay, for a 16 TPI SAE thread, I think we're looking for 68,000th of thread depth, something like that. So anyway, the ideal minor dimension is 2.182, and my tube is currently sitting on about 2.15. It's a bit hard to be exact because of course it hasn't been machined properly. So I'm going to take a 0.01 cut, or 1/10 cut, and we'll see what we've got after that. Alright, well, let's see what we got. Hopefully it's at least round now, that's going to help. So we've got 0.01 to come out, that's on the diameter, so we're 0.005. Let's see if we can make that happen with this worn old lathe. Alright, let's see what we've got now. Alright, let's see what we've got. Well, I'm claiming the luck of the Irish for that. That's not skill. I finished up with 2.1825. And the ideal target was 2.182. Well, I'll take it. Okay, so set up for thread cutting now. I'll have to touch off and then do a scratch pass just to prove I've got the 16 TPI. And because my lathe has a metric lead screw, I'll have to leave the half nuts engaged and back the cutter out. Anyway, let's touch off and check that we've got the right pitch. Now this I've got 16 TPI. Alright, so I've tickled it with a wire brush and put a bit of a chamfer around the outside, a bit awkward at the moment. So this does start in the hole, which is encouraging, but it's a bit too tight still. So we'll run through with another pass. Okay, so I did a couple more spring passes and tickled it with the wire brush. And I'll have to move you out of the way a little bit. This goes in there quite nicely now. It gets tight when it gets to about there, because when I looked closely I realised there was actually a slight taper on the thread. So that's going to be just right for what I'm trying to do. I'm happy with that. Okay, so I'm going to part this guy off at 30 long. I'd like to have the thread that engages with the cylinder barrel some distance away from the weld, just in case of distortion. Oh, there we go. Why is it that what do we call that bit, always hangs onto the piece you want and never on the bit that's easy to clean up? Is it just me, or does everyone have that issue? Anyway, let's go and clean that up and have a look at the next part of the deal. Okay, well I think now you'll be able to see a bit more about what I've got in mind. So I'm creating a body, a pump body if you like, and this adapter ring which I've just finished making on the lathe, screw on the bottom of the pump cylinder. The idea is to weld that on there, hopefully without completely screwing the threads up, pardon the pun. And then I'll have a pair of non-return valves here, one for each direction, and block this end off as well. And then there'll be a reservoir. It's a detail that's to be resolved in the future, probably an old gas bottle, but anyway, a separate reservoir. So that's all fine and dandy. The fittings on the end of these non-return valves are quarter BSP, and I'm not comfortable with the idea of drilling and tapping for these into 3mm thick material. So what I'm going to do is use this 10mm thick material, but because I'm not a very good welder, and I think if I weld that on there, then I wouldn't be able to weld around there, or if I weld around there, then I wouldn't be able to weld that one on. What I'm going to do instead is cut a piece out of this and let this in so that the top's flush with the surface here, and then I'll be able to easily do my drill and weld, and hopefully everything will be fine and dandy. And then I'll just do what I did on this end, which is to weld a piece of 3mm plate across the end there. You wouldn't normally use flat surfaces for anything involving pressure, but this is actually vacuum, and I doubt that it's going to generate an awful much more vacuum than you can probably generate with a healthy set of lungs. We'll see. But either way, I can't see there's any possibility of it collapsing this tube. Well, I hope not anyway. Alright, well that's the game plan, so let's crack on. Okay, so I've marked out the piece that I've got to remove. I'm going to do that on the milling machine, so let's go over there and get started. Getting a good lungful of the coolant spray doing that, so I've got to change my setup. Let's have a look, see how things are going. We'll head off in the other direction at that. Right. You might be able to see better if I lift you up a bit, I think, actually. Yeah, I think you see a bit better like that, can't you? Should have done that before. Right. A bit of a clean up and a proper check. Right. Should be getting somewhere near the size of hole that we want. I'm going to round these corners off as well, rather than trying to make those square. So let's see if we can come back to doing our final sizing. Well, I think you can see that that's going to be fine and dandy. As soon as I've rounded those corners off, I think we'll be golden. So I'll go and do that on the belt sander. Okay, well I think you'll be able to see that that turned out alright. So that fits in there like a thumb in something snug. So what I've got to do now is a bit of beveling for weld penetration and weld it in there. That's the next thing. Okay, so I've done a bit of weld prep on this now. I've V'd out the edges around here. I didn't get carried away. It's not a particularly deep V because this isn't structural steel. Doesn't have to be that strong. So I reckon we're ready to do some welding. Well, I think that turned out alright. I think a key to getting a good result was I changed over to a different welding helmet. And with this one I used for this, I can actually see where the weld puddle's going. Whereas with the other helmet I was using, for whatever reason, I never seemed to be able to actually tell exactly where I was, so I'd always wander off course. Anyway, that's obviously worked out alright. There's a funny looking bit of, there's a little bit of porosity there, but whether that's an issue or not, time will tell. So anyway, I'll get this cleaned up, then I can drill my holes and tap for 1/4 BSP. So I thought, since I've got to do the drill and tap for 2 holes here anyway, I might as well do the cleaning up on the mill as well. How well it's going to show up, but there's certainly some porosity there, so that may well be an issue. I'll have to grind out and re-weld, but the rest of it looks fine. So I decided not to postpone fixing this porosity. So as you can see, I've ground it out, and hopefully I can successfully re-weld that. I've had 3 goes at grinding this porosity out and re-welding it, and there's still coming back, or still traces of it. I don't know, I just have to carry on and worry about it if it becomes a problem when I do the testing. Really have no idea what the cause of it is, because I ground right down past the original weld line and it still came back. I don't know. Well anyway, let's get into drilling and tapping for the 1/4 inch BSP holes. Okay, so drilling for a 1/4 inch BSP tap is 11.8 millimeters. Well, the nearest I've got for that is 29/64, so that's what we're going to use. And let's get tapping. Okay, so I'm going to try out some of this new tapping juice that I've got. See how we go. It's pretty sticky, that's good. Yeah, bit in the hole. Alright, off we go. See how it works. Come on. I might have made I went for 29/64, so I might have been better off going for 15/32s to be slightly bigger hole, so I think that's what I might do. Alright, let's try the tap again. Well, that seemed to work a lot better, didn't it? Right, let's take it out. Oh, I might just deburr the hole, put a slight chamfer on the top of the hole. Yep, that'll do fine. Okay, so time to take this out. Okay, so I think you can see that that's going to work out just fine. So what I'll do now is weld the plate on the end and hope it doesn't leak. Okay, all ready to go, all cleaned up, degreased, and I don't know what else I can do. So I'll attack the corners and then see how we go. Okay, well by my standards that worked out pretty well. Got some hope that that might actually work without leaking. That looks like a gap, but it's actually a little bit of rod, a little bit of wire stuck on the outside. Anyway, so let's clean it up a bit and test it. Okay, well that cleaned up alright, and by my standards that's pretty good. So, time to put a little bit of pressure in it and see what happens. Okay, so I've knocked up a crude little test rig here. So that's one of our non-return valves. That just acting as a T-piece. A pressure gauge and something to relieve the pressure. I'll just pop that off. So we'll clamp that in there where you can see it. And I think the limit of my testing on this is going to be 20 psi. But I've set my pressure regulator here to about 10 psi, something like that, whatever that is in kPas and all the rest of them, kilograms per square centimetre, any other unit you can think of. But anyway, about 10 psi, quite modest. So let's plug that in and see what happens. Yeah. This thing's leaking like anything. Alright, I have to replace that with something that doesn't leak. Okay, take two. I'll replace this with another one. And in fairness, it's possible this is actually designed for 10mm line, whereas this is 3/8. Anyway, let's see how we go this time. That's a bit more encouraging. So we'll take the line off and well, can you see that? Yeah. So that's holding at 10 psi. I can't hear any hissing, and certainly the needle isn't moving, so it's looking very encouraging. I'm just wondering whether to increase it to 20, which would be the absolute maximum I'm interested in, and then let it go overnight. Yeah, I think I might take it up to 20. Okay, so we're holding on 20 and we'll let that go overnight. I'll bring you back tomorrow morning. Okay, well sadly we didn't pass the leak down test overnight. If you look very closely here, I think you better see there's some pinholes, and I'll put it in the water in a minute and you'll be able to see it leaking through those pinholes. And this is really frustrating because I'd already ground out and re-welded this area at least twice, so it's now been welded 3 times. I'm going to have to grind it out and try again. If it doesn't work this time, I'm really not quite sure what to do. Anyway, let's not be pessimistic. I'll put it in the water and show you the leak, and then we'll get on with trying to repair it. Okay, so this water test is actually 48 hours after my first one, as I had other things to do. And when I first did it, there was a continuous stream of very fine bubbles from about there somewhere, plus this one. Well, the very fine stream of bubbles seems to have gone away, possibly because there was a bit of flash rusting and whatever going on in the intervening 48 hours, but clearly I've still got a leak. So that's the challenge, see if I can grind this lot out and nobble that leak. I've ground that out now to probably, I don't know, 3 or 4 millimetres deep, something like that. I just put this bit of pipe in there to protect the thread, and I'll leave it in there when I do the welding. Well, there was a lovely sound of frying bacon when I did that weld, so I'm reasonably optimistic that it's done the business. It doesn't look like there's any porosity there. I'll take that out, clean it up, and retest, fingers crossed. Unbelievably, that's just made it a whole lot worse. Try again, I guess. Well, thank goodness for that. I finally managed to beat that porosity. You can see I got my 20 pounds per square inch on, and no bubbles happening there, thank God. Alright, so we'll let that pressure out. And move on to the next part of the project. Okay, well that welding went about as well as I could have hoped for. There's no sign of pinholes or the dreaded porosity. Haven't tested it yet, but I've got some confidence that that's actually going to work out alright. And the other thing I was worried about was whether or not the distortion would change the shape of the thing, or shrink it, or do anything else stupid to stop this from screwing back in. But in fact that hasn't happened at all. That screws in there quite nicely. So next step is a big hole in there to allow access, of course, into this chamber, and then I better test it as the vacuum pump, which is what I actually want it to be. So, big hole in there. So just as an aside, when I'm using hole saws, I like to use the bigger ones. I like to use spacers. They're selected so that this the saw will do up, the base or the back of the saw will do up tight against the holder, so it doesn't jump around so much. So just look out for washers or shims or something which are about the right thickness to make the hole pattern land in the right place. Like that. So I'll just do that one up a bit tighter, and then those will come just right. The pins will come up through the holes in the back now, and this doesn't flop around, there's no play in it, so you get a cleaner hole. Anyway, just build up a collection of these things. Alright, yeah, I decided to do a big hole in this thing. I couldn't really see there's any reason to do a small hole, unless I could get a rag in there and clean things out, whatever. Okay, well that's given me a pretty decent sized hole. I was able to get a rag in there and clean the piece out. So now I can assemble this thing up properly and see what sort of a vacuum it can generate. I've got an old car tuning vacuum gauge here, so I'll use that so I can get a bit of objective measurement. Alright, I'll bring you back when I've got that all set up. Okay, so I've assembled a bit of a lash up here. That's just a dead end, and I think you'll be able to see the pressure gauge. See if I can generate a bit of pressure. I think that's leaked down past the piston, so we'll put it in the water though and prove that whether that is the case or not. Okay, I don't know how well you're going to be able to see this, but I'll put some pressure on. The water is higher than the weld all round. Oh, I didn't see any bubbles from the weld. Let's do that again. Watching for bubbles from the weld. No, that's not leaking. Excellent. Right, so it's time to pull this apart and reconfigure it to be the vacuum pump that it needs to be for my project. I don't know how well you'll be able to see this, but let's have a go. I don't know how well you could see that, but we've got about 8 inches of vacuum. Okay guys, so I'm going to stop the video here. I've got a working vacuum pump that I'm very happy with. The fact that the vacuum bleeds down quickly from the pump itself doesn't bother me at all, because I have the non-return valve, so this will be able to build a vacuum, hopefully 8 inches of vacuum in an external reservoir. But I can't go any further at the moment because I don't actually have that external reservoir. So at this point I don't know whether this pump's going to work or it won't. But in any case, another reason why it's appropriate for me to stop here, I had a bit of feedback suggesting it'd be better if I aimed or tried to make my videos more like half an hour than heading on towards an hour. It's a bit kinder on people who are trying to find the time to watch them. So that's it for now, and hopefully you can join me in the next episode, and we'll see whether the pump actually works or it doesn't. So thanks for watching. Bye for now.